Hello and welcome everyone. So in the last lecture we saw how we can use Hyperledger Fabric smart contracts and how we can write our own Fabric smart contracts and also deploy them and execute them, and all of them from the command line. So we were executing the smart contracts from the command line using the Fabric PR binary. But that is fine, but in real world applications we need to somehow programmatically access our Fabric smart contracts, right. So in this particular lecture we will see that how we can use Hyperledger Fabric applications to integrate with Hyperledger Fabric smart contracts in order to build decentralized applications or dApps. So we will also see how we use Fabric CAs or Fabric certificate authorities to get Fabric identities and credentials for our applications, and which would be in turn used by the application to execute transactions. So the keywords for this lecture are Fabric application, Fabric CA, and dApps. So let us first see how Fabric applications fit into the overall architecture of Hyperledger Fabric. Right. So if you see this diagram, then we can see that the Hyperledger Fabric PR is the main component through which an organization participates in the Fabric network and interacts with the Fabric's ledger. And this PR is capable of executing transactions, but this PR in order to access this PR we can of course use the Fabric PR binary, as we were doing it from the command line in the last few lectures, to query and invoke transactions. But in order to write applications we need a Fabric SDK, and using that Fabric SDK we can write programs which would be able to send transactions through the Fabric PR, and it would be also able to receive the results back. And optionally there is another feature through which the Fabric application can get can listen for events which are occurring in the ledger. Okay. So in this lecture we will see how we can write this Fabric application. So Fabric application in the broad Fabric architecture actually uses the application developer identity or the organization's identity in general to run, execute or query smart contracts, and these smart contracts are of course deployed within the in the Fabric network, and this application communicates with the Fabric PR to execute these contracts and also receive ledger updates. So the whatever result this smart contract generates, the application can receive that. Okay. So in order to start writing Hyperledger Fabric applications, we need to use one of the following languages. The most supported ones are Node.js and Java, and Hyperledger Fabric also has SDKs for Go and Python languages. So for this particular tutorial we will be using the Node.js or JavaScript language, Node.js, to write our Fabric application. So let us start writing the application, and let us see that how the application will be used to plug into the smart contract that we wrote in the last lecture for getting and putting some data to the Fabric ledger. So we again start from the same folder, Fabric folder, and inside that we have our Fabric samples directory. So here we have the test network. So let us start writing our application, Fabric application, inside this test network directory. Okay. So before that we have to start our network and also start our deploy our smart contract. So we are doing network.sh down first to ensure that everything is cleaned up, and after that we will be starting the network again. So let us just do network.sh and up, but instead of just starting the network as usual, of course we will be creating the channel and passing the special option which is -CA. So this -CA option tells this network.sh script to start the Fabric CAs also. So you can see from this output that it is creating the CA orderer, CA org1 and CA org2. So these are Hyperledger Fabric CAs which will be started. If you don't pass the -CA option as we were doing till now, then the CAs are not run. Instead, when the network is created, the CryptoGen tool is used to create the identities in one time, and we don't need it in future. So CryptoGen tool is fine, but for writing the application we need CA. So if you do docker ps, so apart from the usual containers, fabric PR for org1, fabric PR for org2, then we have the others like fabric tools, the fabric orderer. We also have 3 CAs. This one is fabric CA for org1, similarly fabric CA for the org2, and CA for the orderer organization. So these CA can be used to get the certificates and credentials for different components of an organization. So if you do network.sh deploy cc key value chain code, the chain code we wrote in the last lecture, so it would deploy the chain code in the same way. So it would take some time. So the chain code is packaged and then deployed. So you can see that the chain code installation is successful now. So at this point we have our network and chain code deployed and ready. So we can go ahead and start writing our application. So let us create a folder, name it test app. You can give any name. So this test app folder is inside the test network. Okay. So we will open up a terminal here and start a text editor. So we are using Visual Studio Code again. So let us create a file called main.js, and we will be using it to run our chain code, the application. But before starting to write the application, we have to initialize the Node.js repository. So we do npm init, and this will create a new package.json file with the required details. So it is creating a Node.js project. So I am not changing anything here, just press enter and take the default values. So if you do an ls, you will find that we have the package.json file here. Now we have to actually install 2 packages for writing the Fabric application. Okay, so first one is the Fabric CA client. So we are doing npm install Fabric CA client. So this particular package is required to interact with the Fabric CA from the application. Okay, and the second package that we need to install is the Fabric network. So npm space install space Fabric network. Okay, so we have the packages installed now, and we can go ahead and import these packages in our application. So let us start writing the application. So first we are importing Fabric CA services from the Fabric CA client. So const Fabric CA services equal to require Fabric CA client. Then we will include 2 things. One is the wallet. and another one is the gateway from the fabric network. So, apart from these two, we will need some other packages also. These Fabric CA services, wallet and gateway are the Fabric SDK components that we are going to use. But let us import some other things which would be required also. So, first one is FS. For reading and writing files, we would be reading some configuration files using FS, and then we would require path for parsing the directory paths. So, now we will define a function, and it will be an async function, and then name will be main, and at the end of course, we will be calling this main function. Okay. So, when you run this program, only this main function will be called, right. So, in line 12 currently it is being called. Now, inside that let us first check by doing a console log if the code is working correctly till this point, and if it is able to import all those packages. So, we are doing a simple console log, save it, and then let us go to the terminal and try to run this one. So, for running you can just simply do node space the file name main.js. So, we can see that the console log is coming and there is no error. So, till this point our code is working fine. Okay, now let us start writing the actual Fabric application logic. So, first what we need to do is we need to import the connection configuration file or connection profile for a particular peer. So, it is found in this test network directory under organization, peer organization, then name of the peer. So, if you can easily go to the terminal and check that directory and copy that. So, we can do cat space / organization peer organizations org1.example.com. Now, we have the file in two formats, JSON and YML. So, I will be choosing the JSON one, fine. So, it exists, let us copy this path. So, this is the connection profile and you will find that within this test network directory and paste it here. So, CCP path is the path to the connection profile of org1. Okay. So, since that file is a JSON file, so we will read that file using fs.readFileSync and pass CCP path and UTF-8 and then pass that to JSON.parse. So, what JSON.parse will do? It will parse the JSON and save the contents as a JavaScript object in CCP. So, let us console log CCP and run it and check what is the output and if everything is correct. Okay. So, these steps are reading this connection file and then parsing it and printing it. So, node space main.js. So, yes, so it is being printed. This is the connection profile. You can see the name is test network org1. There are some other informations like the MSP, the peers, the address of these peers, localhost 7051, address of the CA, etc. Fine. So, the next step would be to configure some information about this organization CA, the certificate authority. So, let us first take the CA info from the connection configuration or connection profile. So, inside CCP there are information about the certificate authorities, as you can see here. So, let us take that, and inside certificate authorities we have one CA. So, let us take the name of the CA, ca.org1.example.com, copy that, paste it. So, this is the CA info. Next, let us take the CA TLS CS hearts. So, that is also inside the CA info. So, CA info dot TLS CS hearts dot PEM will give the certificate. So, we can console log that, so that we can see the certificate and check if it is coming correctly. So, this will print the CA TLS CS hearts, which is a PEM file or PEM format. So, this is being printed correctly. This is the certificate in PEM format. So, till this point we have configured the connection profile and also the CA, some information about the CA. Okay. So, another thing we need to configure about the CA, or basically initialize the CA with as new Fabric CA services and pass some arguments and some options. So, we will be passing the CA info.url, and these are some options: trusted routes, and we are passing the TLS heart there, and verify false, and the name of the CA. So, this line will be initializing a Fabric CA services object and saving into this CA variable. Okay, let us demarcate these steps. So, this first step is for configuring the connection profile, and the second step is for the CA. Okay. Now, we can use these two, and we can first create the wallet, which we will use to store the credentials for both the CA admin and also the particular application user. So, let us create the wallet. So, we will take wallet path equal to path dot join the current path, which we can obtain as process dot cwd, and we will name the folder of our wallet as wallet. So, in current path a directory called wallet will be created, and in that directory all the identities will be saved. Next, we are initializing a new wallet as wallet equal to await wallets dot new file system wallet and passing wallet path. So, we can check if wallet is being initialized correctly or wallet path is being taken correctly. Let us print that. Yes, the wallet path is being printed correctly, so we are fine. So, now let us configure the admin identity. So, we need to configure two identities, and for creating a user or creating an identity for this particular application, we need to contact the Fabric CA service, and the Fabric CA can be used only if we have the Fabric CA's identity. So, Fabric CA's admin's identity. So, let us get that. So, we use wallet dot get admin, but this won't work. Wallet dot get admin will return empty because the wallet is empty and it is only created in line 24. So, what we need to do instead is we need to use CA dot enroll and pass enrollment ID as admin and enrollment secret as admin PW. Okay. Now, let us check from where this admin PW is coming from. So, if you go to this test network, inside the Docker folder you will have this file docker compose ca.yml. Open up this one, and if you open this one, you will see that indeed the test network is defining two CAs, one for OR1, one for OR2, sorry 3 CAs, another one for orderer, and in each of them you can see the admin and admin PW. this admin and admin PW is being used while starting up the CA. So, this admin is the identity and admin PW is the secret. Okay. So, enrollment ID and enrollment secret. So, we are using admin and admin PW to enroll the CA's admin using this ca.enroll, and finally, we will be getting the X509 certificate of the CA through this enrollment dot certificate and enrollment dot key dot 2 bytes line. Let us see if it is working correctly by console logging this one. So, before that, let us put that into the wallet. So, wallet dot put admin and then this identity, fine. So, console log admin enrolled and save to wallet. So, after it is saved to wallet, of course, we can now do await space wallet dot get admin. So, similarly, we will be now registering a user and its identity for this particular application. Okay. So, in order to make and execute transactions, this application must have some identity, and from where will it get the identity? It will get the identity from this particular CA using this CA's admin. Okay. So, we can do var user identity equal to wallet dot get and then do app user, you can name it anything. So, of course, at first the wallet will be empty and it will not have this app user identity. So, this if user identity will fail. So, if it exists, we can say user identity exists, otherwise in else we can just start getting the identity and saving into wallet. So, else so, we will be doing const provider equals to wallet dot get provider registry dot provider and then admin identity. So, we need this admin identity and we will be using it to get one identity registered for the user. Next, we will define admin user as provider dot get user context, then passing the admin identity and admin. So, it will get the admin user and then using this admin user we will create the certificate and credentials for the app user. So, we will do ca dot register and it will take an enrollment ID which is app user, a role which is client. So, for this particular application the role is client since it is a Fabric client application, and it takes also one affiliation called org1 dot department 1. So, since this client belongs to org1. So, this is the secret, and using this secret we can use we can call ca dot enroll and pass this secret along with the name of this identity which is app user. So, after this we can go ahead and get the X509 identity and also save the identity to a wallet or to our wallet. So, this X509 identity is being fetched from the enrolled identity for the user, and it is similar to the admin, the C admin as we wrote earlier. So, we are saving enrollment dot certificate and enrollment dot key into X509 identity. Okay. Now, we can simply save this into the wallet. So, await wallet dot put and app user and save the X509 identity there. Fine. So, let us console log this. Okay. So, till this point we have configured the identity of the admin and also the admin of the CA and also the app user. So, next we will go ahead and define the lines of on how we can execute an smart contract from this application. So, let us run it till this point. So, it is working fine. You can say admin enrolled and saved into wallet and enrolled app user and saved into wallet. If you run this again, then it will say that user identity exists in the wallet because it got created the first time we ran it. Okay. So, next we will be writing the logic on how to connect to the Fabric network and how to execute a particular chain code. So, we are doing const gateway equal to new gateway. Now, this is a gateway, and from this gateway we need to connect it to the Fabric network and a particular channel. So, first we will do gateway dot connect and pass the connection profile CCP. Next, and it will also take some options like the wallet, the identity that should be used, which is app user, and discovery. Okay. So, wallet is coming from here and CCP we have defined earlier, wallet we have also defined earlier. So, everything is fine, and discovery will take two arguments, enabled true and as localhost true, since we are using it in the test network. Okay. Next we would be now the gateway is connected to the network. Next we have to define which channel we want to connect to and which contract we want to execute. Okay. So, first let us do the channel. So, we will do const network equal to await gateway dot get network, and we will have to pass the name of the channel, and we are using my channel. So, we will pass that. Next we have to specify which smart contract or which chain code we want to execute. Okay. So, we would do const contract equal to network dot get contract, and we have to pass the name of the contract. So, the name of our contract was key value chain code. Let us confirm that. Yes. So, key value chain code, copy it, paste. Fine. So, after this we can do both query and invoke. So, this particular key value chain code can store and get results or get key value pairs from the ledger. So, let us first do contract dot evaluate transaction, and then it will take the name of the function that we want to evaluate or query and the argument. So, query key takes only one argument, which is the key. So, we are trying to query the NPTEL key. Next we are doing console log result and converting it into string. Okay. Fine. So, if we query NPTEL, let us see what happens. Let us run our code. We can see that first query is empty. So, it is returning an empty string. So, it is not giving us anything. Fine. This is because we have deployed the contract and we did not invoke it anytime, and the NPTEL key does not have any value stored into it, stored corresponding to it. So, let us go ahead and store something. So, for that we would do await contract dot evaluate transaction. Sorry, this will be send actually, because we are submitting a transaction. So, submit transaction, then create key, and it would take two arguments, the name of the key and the value that we want to save, correct. So, we are saving suppose any string, let us say awesome. So, for querying we are using evaluate, and for submitting we are using submit transaction. Okay. So, evaluate transaction and submit transaction are a bit different. Evaluate are for queries, submit are for transactions which change the world state. So, it is actually changing something in the ledger. Let us query it again and name it second query, fine. So, after this it is good to actually disconnect this gateway. So, we can do await gateway dot disconnect. Okay. So, let us go ahead and run this again. So, we can see that the first query was empty and the second query is awesome. Okay. So, it is working correctly. So, it is being able to store and also retrieve values. So, you can change it to any new string, create key. So, we can say a new value and run it again. So, this time you see that the first query returned awesome, because the last time we already stored NPTEL corresponding to NPTEL awesome. Now, after that we stored a new value and that is being displayed here. So, we saw that how we can write Fabric application, and the broad steps that we followed are first importing the prerequisites, which are the Fabric CA network and Fabric network coming from the Fabric SDK. Then we define the connection profile and some information about the Fabric CA from the connection profile itself, and we also define the Fabric CA services. And after that we configured the CA admin, and then we registered the user for this particular client application. Then we saw that how we can connect this particular client application to the Fabric network and one particular Fabric channel, and also how we can select the chain code which we want to execute. Then we did some queries and invoke transactions to that chain code, and in this way we can actually use this Fabric application to interact with the chain code, any chain code that we write. So, in conclusion, we saw that we can use Hyperledger Fabric to write our own smart contracts. So, we can write any business logic and encode that into a smart contract, deploy that in a Fabric network, and then write our own Fabric applications to interact with those smart contracts, and in that way ultimately develop decentralized applications or dApps in this permission network. So, in this particular lecture we covered Fabric client SDK, how Fabric CAs issue identities, and those identities are used by the client applications and other components to execute transactions, and then we wrote a Fabric client application and used that to query and invoke chain codes. So, ultimately we through these 4 lectures we covered the Hyperledger Fabric platform, how, and we saw how we can write our own chain codes and our own applications, and hence build dApps in this permission platform. Thank you.